You ever feel like your project timeline is just less a straight line and more like tangled spaghetti?
Happens all the time.
Or you watch one small delay just cascade, creating this logistical nightmare. It's a huge challenge,
Right.
right? Orchestrating everything to land just when it's needed.
Absolutely. And it's everywhere. Big companies, hospitals, universities.
Yeah.
Getting it right is, well, critical.
It really is. It's less about just having a calendar, isn't it?
Oh, much more. It's a whole strategic framework that kind of underpins everything.
Exactly. So welcome, everyone. We're doing a deep dive today into scheduling. It's maybe an underestimated part of operations and supply chain management.
Yeah, people hear scheduling and think calendars.
Right. But it's not just blocking out time. We're talking about strategic decisions, decisions that hit your bottom line, customer service, and ultimately, your competitive edge.
And for this dive, we're drawing from Vishnu Rayapeti's OpEx SCM Funda5 Scheduling. Our mission really is to unpack the core ideas, the methods, and honestly, the sometimes surprising implications of doing scheduling well.
Yeah, help you cut through the noise and get to what matters.
Mm-hmm.
And what jumped out at me right away is how good scheduling lets you get more out of the assets you already have, more capacity per dollar.
Which directly lowers costs.
Directly. And at the same time, you get faster delivery, better customer service. It really can be a strategic game changer.
And it's important to note, our focus today is specifically on short-term scheduling. We're talking about the actual timing of operations.
So really granular stuff like hourly, daily, maybe weekly.
Exactly that level.
Okay, so we're not talking about, say, deciding how big the factory should be, that long-term capacity planning.
Nope, not that. And not the intermediate stuff either, like aggregate scheduling, overall production levels, staffing.
Or even the master schedule that feeds into MRP systems.
Right. We are zooming way in. Short-term scheduling is about work center loading, assigning specific jobs to machines or teams, and job sequencing.
Sequencing meaning the exact order you do those jobs in.
Precisely. Which job runs first, second, third.
And, okay, we think factories, maybe, but you mentioned hospitals, universities.
Oh, absolutely. Think about coordinating outpatient treatments or operating room schedules. Hugely complex.
Or even just getting the right professor in the right classroom at the right time.
It's the same fundamental challenge. Mashing resources to demand efficiently.
Got it. So when you actually approach scheduling, are there like main ways to do it?
Generally, yeah. Two fundamental approaches pop up, forward scheduling and backward scheduling.
Okay, forward scheduling sounds straightforward.
It kind of is. You basically start the schedule as soon as you know the requirements. You get an order, you start making it.
Makes sense for like custom jobs.
Exactly. Often used for jobs performed to customer order. The upside is you start immediately. The downside?
Let me guess, you might finish late.
You might finish after the due date. And it often causes a buildup of WIP, work-in-progress inventory.
Ah, WIP, the silent killer.
It can be. Now, backward scheduling is the inverse. You start with the due date of the final step.
The very end.
The very end. And then you schedule everything else in reverse order from that point.
Okay, so if something's due Friday, you figure out Thursday's work, then Wednesday's, working backwards.
That's the idea. You see this a lot in manufacturing, where hitting deadlines is crucial. Also, catering. The meal has to be ready at 6 p.m., not sometime Friday.
Or surgery, you mentioned. That makes perfect sense. The recovery timeline dictates the start.
Exactly.
It's a totally different way of thinking, isn't it? One starts today and pushes forward, kind of hoping to hit the date.
While the other starts from the date and pulls backward, creating these hard deadlines for every step before it.
Yeah, implies a very different approach to managing expectations and inventory too, I suppose.
Definitely. Which brings us to a really important question. Why bother? Why put so much effort into optimizing these schedules? What are we actually trying to achieve?
Good question. What are the main goals?
Typically, there are 4 big ones. First, minimize the total time it takes to complete all the jobs. Get things through faster.
Okay, speed. Makes sense.
Second, maximize utilization. Make sure your people and your expensive equipment are actually working effectively, not sitting idle.
Efficiency. Got it.
Third, minimize that WIP inventory we talked about. Keep the amount of stuff stuck in the middle of the process low. Less cash tied up.
Right. Minimize inventory. And the fourth?
Minimize customer wait time. Pretty straightforward, but crucial for service.
Speed, efficiency, low inventory, happy customers. Okay, those make perfect sense. But hitting those goals probably isn't easy. How do you actually choose the right scheduling method? There must be loads.
You're right. It's definitely not a simple choice. It's not one size fits all. You have to consider um, qualitative things first.
Qualitative like.
Like, how many jobs are you juggling? How different are they? How complex are the actual steps involved? What's the basic nature of your operation?
Okay, the feel of the situation.
Kind of. And then you layer on the quantitative criteria, the hard numbers.
This is where we measure performance.
Exactly. Things like the average completion time across all jobs, the utilization percentage, how busy are things, really, the average number of jobs physically in the system at any one time, and crucially, average lateness. How often are we missing due dates?
So you use those numbers to compare different scheduling approaches.
That's the idea. And the best method can change dramatically depending on your process type. From very standard level-loaded systems.
To the other extreme, like process-focused centers, the ones doing custom work.
Precisely. Those places handle high variety, low volume, often custom-made products. And that inherently means much more complex planning, loading the work centers, and especially sequencing the jobs. It's a trickier puzzle.
Right. To even start solving that puzzle, you need good information, I assume.
Absolutely fundamental. You typically rely on specific types of planning files.
Okay, like what?
Well, first, there's your item master file. This basically has all the details about every single component you make or buy. Part numbers, descriptions, maybe costs.
The encyclopedia of parts.
Pretty much. Then you have the routing file. This is crucial. It tells you the exact path, the flow, each component takes to the shop. Which machine in what order.
The roadmap for each part.
Exactly. And third, the Work Center Master File. This holds the key info about the work centers themselves, the machines, the teams, things like their capacity, how many hours they have, maybe their efficiency rates.
Okay, so you've got the parts list, the roadmap, and the info on the workstations. Yeah. Now you actually have to load the jobs, right? Assign them.
Yes, that's the next big challenge. Yeah. Assigning jobs to work centers. And here you're balancing job priority, like which one is due soonest. Against the actual capacity.
Does the work center even have enough hours available for this job compared to how many hours the job needs?
That's the core question.
Yeah.
One classic tool people use here, very visual, is the Gantt chart.
Ah, Gantt charts. Seen plenty of those.
Right. They can work as load charts, showing you how much work is piled onto each machine or team, kind of a snapshot of the workload.
Or as scheduling charts.
Or as scheduling charts, yeah. Where you see the specific activities, when they're scheduled, maybe even track actual progress against the plan. And show non-production time, like maintenance.
They seem useful, but I always feel like they go out of date the second something unexpected happens.
That's their big weakness.
Yeah.
They don't inherently handle surprises, machine breakdowns, rush orders, you name it.
So they need constant updating to be worth anything.
Constant, rigorous updating, absolutely. Now, for a more analytical approach to loading, there's something called the assignment method.
Assignment method? Sounds mathematical.
It is. It's a type of linear programming model. Think of it like a specialized tool designed purely to assign tasks or jobs to resources in the best possible way.
Best possible meaning?
Usually minimizing the total cost or the total time it takes to get all the assigned jobs done.
How does it work, generally?
It sets up constraints like, okay, each job can only go to one resource, and each resource can only handle one job at a time, typically. And then the mass finds the optimal pairings, the best match to hit that minimum cost or time objective.
Interesting. So it finds the mathematically perfect assignment.
In theory, yes, based on the data you give it.
Okay, so let's say we've loaded the jobs, maybe using Gantt charts or this assignment method. Now the jobs are sitting at the work center. The really crucial question comes next, right? Which one do I actually run now?
Exactly. This is sequencing, specifying the order. Which job gets processed first, second, third.
And this is where those priority rules come in.
This is precisely where priority rules drive the decision. And there are several common ones, each with its own flavor.
Let's hear them. What's the simplest?
Probably first come, first served, FCFS. Just like it sounds, the first job to arrive at the work center gets processed first.
Like waiting in line at the deli?
Exactly. Performance-wise, it's usually kind of average across the board. Yeah. But its big advantage is that it seems fair to customers. That perception can be really important, especially in services.
Okay, fair, but maybe not fastest. What else?
Then you have shortest processing time, SPT. Here, you pick the job that will take the least amount of time on that machine next.
Prioritize the quick wins.
Sort of. SPT is usually the best rule if your main goal is minimizing the overall job flow time and minimizing the number of jobs just sitting around in the system. It keeps things moving.
Sounds great. What's the catch?
The major disadvantage is that long jobs, the ones that take a lot of time, can get pushed back and back and back again if short jobs keep arriving.
Ah, so the big important job might never get done.
It can feel that way. It gets perpetually bumped down the queue.
Okay, so FCFS is fair, SBT is fast, but potentially unfair to long jobs. What about due dates?
That brings us to earliest due date, EDD. You prioritize the job that needs to be finished soonest.
Seems logical, especially if deadlines are critical.
It is widely used, yeah, especially if due dates really matter, or if you're using an MRP system that generates those dates. But interestingly, while it's good for timeliness, EDD often performs poorly on other measures, like machine utilization or average flow time.
Huh. So hitting the date might make other things less efficient.
It can, yeah. Then, just for completeness, there's the opposite of SPT, longest processing time, LPT.
Run the biggest job first. Why would you do that?
Honestly, it's almost always the least effective method. The data usually shows it performs worst across most scheduling criteria. We mentioned it mainly as a contrast.
Okay, so avoid LPT. Got it. FCFS, SPT, EDD. Feels like something's missing. What if a job isn't due for a while, but it takes a long time to do? How do you balance urgency and workload?
Ah, you've hit on the magic. That's where the critical ratio, or CR, comes in. This one is really powerful.
Critical ratio. Okay, what is it?
It's a dynamic calculation. You take the time remaining until the due date.
Due date minus today's date.
Exactly. And you divide that by the work time still remaining on the job, the lead time left.
Okay, so time left divided by work left. What does that ratio tell you?
A ratio less than 1 means you don't have enough time left. You're already projected to be late. A ratio equal to 1 means time equals work. You're on schedule. Greater than 1 means you have some slack.
And how do you sequence with CR?
You process the jobs with the smallest CR first. Those are the most critical ones, the ones closest to being late or already late.
That sounds really smart. It's dynamic.
It is. It performs really well on average lateness. But its real power goes beyond that. It lets you see the status of any specific job instantly.
Like a health check.
Exactly. It gives you a common yardstick to compare all jobs, stock orders, custom orders, doesn't matter. And here's the kicker. It automatically adjusts priorities. If demand changes or if a job gets delayed, the CR changes and the schedule adapts dynamically.
Wow. Okay, that sounds like the superhero of sequencing rules.
It's certainly very sophisticated and adaptive.
So let's make this real. You mentioned comparing these rules with data. How much difference does it actually make?
Oh, a huge difference. This is where you really see the impact. Let's imagine we have, say, 5 jobs, A, B, C, D, E. Each has a processing time, like how many days it takes, and a due date.
Okay, a simple scenario.
Simple scenario. Now, apply the rules. If you run them first come, first served, maybe your average completion time across all jobs is, let's say, 15.4 days. And maybe your average lateness is 2.2 days.
Okay, a baseline.
Now switch to shortest processing time, SPT, for those same jobs. Remember, SPT focuses on speed. Your average completion time drops significantly, maybe down to 13.0 days.
Wow, over 2 days faster on average.
Yeah, and your utilization jumps up, say, to 43.1%. And the average number of jobs just sitting in this system goes way down. SPT really clears the BECs.
But potentially makes long jobs late. What about EDD, earliest due date?
For those same jobs, EDD might not be the absolute fastest overall, but it nails the lateness metric. Maybe it brings average lateness down to just 1.2 days. If avoiding lateness is your absolute top priority, EDD shines.
Okay. And LPT, longest processing time.
LPT, for those same jobs, disaster. Average completion time might balloon to 20.6 days.
Compared to 13 for SBT.
Exactly, and average lateness could be a painful 9.6 days. The numbers make it crystal clear. LPT is just generally a bad idea.
The data doesn't lie. Choose your rule based on what you prioritize: speed, on-time delivery. But probably not LPT.
Pretty much. Yeah. And if you calculated the critical ratio for each of those jobs based on their due dates and remaining work time, you'd get a totally different sequence again, maybe A, then C, E, B, D, or something like that, processing the smallest CR first, aiming for that balance of timeliness and flow.
It's fascinating how much difference the sequence makes. But these rules, even CR, they sound great, but reality is messy, right? What are the limitations?
That's a crucial point. Scheduling isn't static. It's incredibly dynamic. These rules, they often need tweaking, revising, process changes, equipment breaks. The mix of products people want shifts.
So the rules aren't set and forget.
Definitely not. And another big thing, many IPL rules, they don't look upstream or downstream. Meaning, the rule might tell you to run job X next on machine 1, but it doesn't realize that machine 2 down the line is completely idle, starved for work, or, conversely, It doesn't see that machine 3 is a huge bottleneck, and feeding it more work right now is pointless.
It has tunnel vision, just looks at its own little station.
Exactly. And often, they don't look beyond due dates. They focus solely on hitting the date, which is important, but sometimes might mask bigger systemic problems or opportunities for overall improvement.
So powerful tools, but use with awareness of the bigger picture.
That's the key.
Now, we've talked a lot about factories, work centers. How does this translate to services? Is scheduling just as important there?
Absolutely vital, just looks a bit different sometimes.
Yeah.
Think about it. Your doctor's office uses an appointment system, right? That's pure scheduling.
Trying to balance patient flow, doctor time.
Exactly. Restaurants, car rentals, they rely on reservation systems. That's scheduling capacity.
Your local deli counter.
Probably simple, first come, first served, still a scheduling rule.
And a hospital emergency room.
That's often most critical first. Another priority rule, driven by urgency, not arrival time or due date. The core challenge, managing flow, capacity, demand, it's universal, even if the tools look different.
That makes a lot of sense. So wrapping this up then, we've really gone deep into this hidden world of scheduling.
From the big picture scope down to the nitty-gritty of priority rules.
Yeah, understanding forward versus backward, the goals, those different rules like FCFS, SPT, EDD, and especially that powerful critical ratio.
And seeing how those choices impact real numbers, completion time, lateness.
It really shows you the levers you can pull for efficiency, for customer satisfaction, for just getting that competitive edge, whether it's a factory or a hospital.
Hopefully you, the listener, feel pretty well informed now on what can be a complex topic, but one that's just so critical.
Yeah, armed with some practical insights. So here's a final thought to leave you with. It's scheduling, in some form, touches almost everything we do, commutes, personal projects, everything. What's one small adjustment you could make, maybe inspired by these principles, like thinking about SBT for your quick tasks, or EDD for your deadlines, or even a personal critical ratio that might have a surprisingly big impact on your own, let's call it personal operational excellence?
Interesting question. How might understanding these rules change how you prioritize, or even just how you feel waiting in different lines?
Something to think about.